When we balance a redox reaction, we often use a technique called balancing by half reaction. So as we've learned already, when we have a redox reaction, we're looking at a net movement of electrons. And so we can account for the electrons by looking at the half of the reaction that undergoes oxidation and the half of the reaction that undergoes reduction. So we can split it apart. We can balance the oxidation half, we can balance the reduction half, and then we can put it all together to come to our overall reaction. Okay, so when we balance by half reaction, we start off with just a skeleton reaction when we're looking at just the parts of the reaction that contain the species that are oxidized or reduced. We put them into the half reactions. So when we divide this, okay, we're going to assign our oxidation numbers. So that way we can figure out what's the oxidation half reaction and which one's the reduction. This helps us because we know that our oxidation, we have to have electrons as a product. And for our reduction, we have to have electrons as a reactant. Now we're assuming that these are all occurring in aqueous media. So if we make that assumption, then we have water floating around. So what we'll do is we'll first balance anything that's not oxygen or hydrogen. And then we can balance oxygen using water. And then we can balance hydrogen using H+ ions. So we're going to start off by also assuming that we're in acidic media. There's one extra step that we do for in basic media. And then we look at balancing charge with electrons. So once we have everything balanced other than charge, we do the charge last, and the charge has to be balanced with electrons. Now, remember that we're looking at a net movement of electrons, right? So what we then have to do is we have to do a multiplication by an integer to make sure that the electrons can cancel out. Then we'll add up everything together, make sure it all looks good, and we'll double check to make sure it is balanced. Now, if we are in basic media, well, we're not going to have H+ ions floating around, but we'll probably have hydroxide ions floating around. And so what we'll do is we'll cancel out the H+ ions with hydroxide ions, make some water, and balance it out from there, okay? All right, this sounds like a lot, but we're gonna go ahead and give it a shot. We're gonna try an example. We're gonna balance it first in acid and then do that last step for balancing in base, okay? So the reaction we're going to look at is we're gonna take a dichromate ion, and an iodide ion, and we're going to get a chromium-3 ion and some iodine. Okay, that's floating around in water. So what we'll do is we will first assign our oxidation numbers. So oxygen gets this -2. There's 7 of them, overall -2 charge, 2 chromiums, I get a +6. A single iodide ion is a -1. A single chromium-3 is a +3, and iodine in its elemental state is a 0. Okay? So once we have those, now we can split up into our half reactions. So our dichromate ion, we're going to get, actually no, I'm going to need some more room than this. We might have to add stuff to both sides of the equation, so I'm going to give myself some more room. Okay, now as I'm balancing this, I don't worry about the state labels because it just gets cumbersome. Okay. Okay, so chromium goes from a +6 to a +3. So did we get more positive or more negative? We got more negative, right? We went down to a +3. So our chromium is going to be reduced. Iodine went from -1 to 0. So is that more positive or more negative? It's more positive. So iodine is going to be our oxidized species. Okay. Now I went from +6 to +3 and I had 2 chromiums. So we're going to have a net movement of 6 electrons. Okay. So there's my chromium and then my iodine. Okay, and then we have 2 iodines, so we'll have a net movement of 2 electrons. All right, so let's take a look here. So chromium, we have to balance off anything other than oxygen or hydrogen first. So I have Cr2, and I only have one chromium here, so I'll put a 2 there. Now, I've got some oxygens on that dichromate ion. So I balance oxygens with water. So if I have 7 oxygens, I need 7 waters, okay? And then if we're in acidic media, if we have H+ ions floating around, well, I balance off my hydrogens with H+ ions. So 7 times 2 hydrogens is 14. I don't have any already on my reactant side, so I need 14 hydrogen ions, okay? Now I have to balance my charges. And at this stage of the game, the only thing I have available to me are electrons, okay? And electrons are what charge? Positive or negative? They're negative. So I have negative charges available to me. So if I look at this, right now I have plus 14 minus 2. 2 times 3 is plus 6, and water is neutral. So I have a net of plus 12 over here and a net of plus 6 over here. Okay, and so remember, what we need is we need to make sure that the charge balances. So 12 does not equal 6. And all I have left right now are electrons, so I have to figure out a way to make 6 equal 6. Okay, because I can't get more positive, I can only get more negative. So I have to add 6 negative charges over here. So now, minus 6, oh, now I get a plus 6. Plus 6 equals plus 6. And remember, we had 2 chromiums, each having a movement of 3 electrons, because 6 to 3 is 3. Well, 3 times 2 is 6. Oh, we have a net movement of 6 electrons. So it all works out, right? And we said the chromium was reduced, and where did our electrons end up? They ended up on the reactant site, so we did that correct. All right, now let's take a look at the iodine. This one's going to be easier because we don't have any oxygens or hydrogens. All right, so I have 2 iodines here. I'm going to put 2 there. 2 times negative 1 is negative 2. This one's a 0, so I'm just going to put 2 electrons there. Okay, so we have balanced our half reactions. Now what we have to do is we have to put it all together, though, so that the electrons cancel out. All right, well, I can't cancel the electrons right now because 6 and 2 do not equal each other. But can I do something to one of these to make the electrons cancel? Yes. I can multiply this whole thing by 3. So 3 times 2 is I'm going to get 6 iodide ions, 3 iodines, and 6 electrons. Okay? So far so good. Now I'm going to move to another page so I have room to write. All right. So we have our 6 electrons plus our 14 hydrogens plus our dichromate, giving us chromium and our 7 waters there. Okay, now I like to line these up so that it's easier to see where everything goes. So I'm going to have my reaction arrow here. So I had 6 of these, and then I had 3 of these. This is after I did that multiplication, and I had 6 electrons. Okay, so at this stage, if we did everything correct, the electrons cancel. So 6 electrons on my reactant side, 6 electrons on my product side. Boom, they cancel. So we're good there. Now we go through and we cancel out anything else that shows up on both sides. Well, in this one, we only had waters and hydrogen ions in 1/2 reaction, so we're good. So we can go ahead and put this together. Okay, I like to put my waters and my hydrogen ions on either end, and you'll see why in just a moment here. Okay, so if we were in acid, we would double check at this stage, and then we'd be done, and we could rewrite with our state labels, okay? So done if in acid. Actually, no, I want to make sure that I have room for this next step. Okay, so here would be done if we were in acid, but what if we were in base? Well, again, in base, we don't have hydrogen ions floating around because excess H+ ions means we're acidic, right? In base, we have hydroxide ions floating around. So what we're going to do is we're going to cancel out the hydrogens with some hydroxides and then cancel out any waters. So if I have 14 hydrogen ions, how many hydroxide ions do I need to get rid of all of them? I need 14. So I'm going to add this to both sides. Okay, so I add that to both sides. Okay, 14 hydrogen ions, 14 hydroxide ions gives me 14 waters. Okay, now I have 14 waters on my reactant side and 7 waters on my product side. So I can't have the same thing on both sides of the equation. So 7 is less than 14, so I get rid of all of those. 14 minus 7 is 7. Okay, so now I can rewrite this whole thing. 7 waters, my dichromate ion. My iodide ion, my iodine's floating around in solution, my chromium 3 ions, and my hydroxides. Okay. Oh, I missed a 2. Okay. All right. And so that's how we balance by half reaction. So what I have here is just basically what we just did. Okay. Written out because there's a lot here. And then I've got a couple more examples. All right, so I've got a mercury one and an aluminum one here. One's in acids and one's in acid and one is in base. So as usual, what I want you to do is I want you to pause and then I want you to try and then I want you to see how I did it. All right, let's take a look at that mercury example. If I can write correctly. Okay. All right, and then our oxidation numbers. All right, so we're gonna have a mercury half reaction and a sulfur half reaction. And so your mercury half reaction should look like this. All right, and your sulfur should look like this. Okay. All right, now 2 and 16 aren't going to cancel each other out. So I need to multiply this one by 8. Okay. So we're going to get this. Okay, and then my electrons cancel. And we end up with okay, and this one was listed as being an acid, so that's it. We don't have to do anything else. All right, the next one is a little more complicated though, and that one I've listed as in base. Okay. All right. Writing too fast. Okay, so there's the oxidation numbers on that. Okay. All right, so now your half reactions on this one. Okay, so that's what you should get for the aluminum. And then for the nitrogen. Okay, so hopefully you were able to get that much at least. Now 3 and 8, well, the only thing we can do is multiply this by 3 and that by 8. Okay, so we're going to get some much bigger coefficients this time around. All right, so we're going to get something that looks like this. Okay, and then for our nitrogen, we're going to get all right, so we've got a lot of stuff going on in this one. So the first thing we need to check is, do our electrons cancel out? So we get, yes, those cancel out. Now, I look at my waters, okay? On one side, I have 32 waters on the reactant side, and on the other one, I have 9 waters on the product side. So we're gonna have some canceling out. 9 is less than 32, so all of these go away. 32 minus 9 is 23. Same thing with my hydrogen ions. I have 27 on one and 32 on the other, so 27 is less than 32. So the 27 goes away, and this drops to 5. Okay? All right, so now we put this together. Okay, so there's 1/2 of that, and then our reactant half. Okay? Now, if you remember the slide that had this problem on it, it listed it as being in base. So we've got to neutralize off those waters, or not those waters. We've got to neutralize off those hydrogen ions into waters. So we're going to add hydroxide to each side. We need to have 5 of them. Okay, so now I have water on both sides again. Okay, there we go. That didn't show up. Okay, 5 is less than 23, so these go away, and this becomes 18. Okay? So this one's a little more complicated. Okay, so we'll put it all together, and we're going to get something that looks like this. 5 hydroxides, 18 waters, 8 aluminums, 3 nitrate ions, 3 ammonias, and 8 there we go. Almost ran out of room. Okay, so that is balancing by half reaction. These take a lot of practice. You can watch me do them all day, think you understand it, and then go home and realize, oh, wait, I don't know what she's doing. So what I have is at the end of these slides, I have a ton of practice problems for you to try. I also have all the final answers typed out, not the full solutions like this, but the final answers. You need to practice them, okay? Absolutely, 100%, you need to practice them. You will not get this down if you just look at a few things that I do and just copy what I write. You have to work with this. It can be a little bit of a struggle. Redox, I know, can be a little confusing and a little kind of upside down and backwards for a lot of students because we're talking about the movement of electrons, and electrons are negative. And so oxidation is a loss of electrons and getting more positive. Reduction is a gain of electrons and getting more negative. All right, so engage with this, practice. It's the only way that you'll start to solidify it because there's a lot of steps here. All right.